Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in finding some leaves in a given binary tree. First, let us take an example. The idea is to traverse the tree starting from root. For every node, check if it is left subtree is leaf. If it is true, then we add it to the result. Now, let us see the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node, which is 9, along with 0 for boolean variable is left and 0 for sum to left leaves some rec function. So, root points to 20 and is left and sum will be 0. Since root is not null, we check if node is a leaf node or not. Both left and right children of 9 exist, it is not a leaf node. Next, we recursively call the left and right subtrees using a call stack. Note, we pass 1 for left child in boolean is left variable and 0 for a right child. Now root will point to 8, which is the left child of 9. Again, since root is not null, we check if it is a leaf node. As it is false, we pass the left child of 8, which is 5, along with 1 for is left. Now as 5 is a leaf node and is left is true, we add 5 to sum. So sum will now be equal to 5. We pass the left child of 5, which is null. As root is pointing to null, we return. Next, we pass the right child of 5, which is also null. Again, as root is pointing to null, we return and finish execution for node 5. Execution for node 8 is resumed, and now we pass the right child of 8, which is null. As root points to null, we return to the previous call and finish execution for node 8. Execution for node 9 is resumed, and now we pass the right child of 9, which is 6. Since root is not null and it is not a leaf node, we pass the left child of 6, which is 1. Now, as root is not null and it is a leaf node and is left is true, we add 1 to the sum. So, sum will now be equal to 6. We pass the left child of 1, which is null. As root points to null, we return to the previous call. Now, we pass the right child of 1, which is also null. Again, as root points to null, we return and finish execution for node 1. Execution for node 6 is resumed, and now we pass the right child of 6, which is null. As root is null, we return. Execution for node 6 and node 9 is over, and we have the final sum, which is 6. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.